Hey guys, Miss King again, and in this screencast, we're going to look at microscopes. So first of all, there's different kinds of microscopes, and the kind of microscope that we are going to use in class is called a compound light microscope. This type of microscope uses multiple lenses, glass lenses, to magnify our objects. And usually our magnification can go anywhere from 1,000 to 1,500 times with a compound light microscope. There's also what's called a scanning electron microscope, or an SEM. And an SEM can scan, and usually we see only surface type images, 3D images, but those images can be magnified up to 60,000 times. So that will give us a much better image than a light microscope. And then we also have what are called transmission electron microscopes, or TEMs. And these allow us to actually see through a complete specimen, so we can see the details and the things on the inside of the items that we're trying to look at. So these types of microscopes can magnify hundreds of thousands of times. So we can see some of the tiniest things in existence, including individual atoms and molecules, with this kind of microscope. So if we compare some images, if we were to say look at blood cells under these three different kinds of microscopes, the compound light microscope, we would see something kind of like this. So each one of these little circles is our blood cells. And then the SEM, the scanning electron microscope, would look something kind of like this. So it shows us the surface, but it's much more detailed, and it's much closer up in the image. You can see that a whole lot better. And then if we were to look at our transmission electron microscope, we could actually see inside the red blood cell. And you can see on the inside of that cell there are lots and lots of tiny little parts. So let's take a look at our compound light microscope. There are lots of little parts and pieces that we need to know how to operate when we're using our light microscopes. So let's start at the top. Up here, number 1, this little piece right here is called the eyepiece. And its function is to hold the ocular lens. So there's a lens up here that you can look through. Our second part, number 2, is called the coarse objective knob. That's the big one. And its job is to move the stage up and down to focus our image. Number 3, the smaller dial, is called the fine objective knob, and its function is to sharpen the image. Be careful not to mix up the coarse objective with the fine objective. Focusing is not the same thing as sharpening, so be careful with that. The next piece, number 4, is called the objective lens. It's going to magnify our image for us, and there's actually multiple objective lenses. So over here, number 9 and 10 are also objective lenses. The smaller the lens, the lower the magnification. So this would be a low power objective lens, and then we would have a medium power objective, and then this long objective lens would be our high power objective. The next part, number 5, this area of our microscope is called the arm, and its function is to support the microscope while it's being carried. So if we were to take our microscopes from a cabinet to the lab station, we would have to use the arm to support our microscope. And then this little dial down here at the bottom is called the inclination joint, and that little guy is going to help us tilt the microscope. Over here on this side, we have this tube right here is called the body tube, or the body. And its job is to connect the eyepiece with our objective lenses. The next piece, number 8, is called the nose piece. That's this circular piece right next to our objective lenses, and its job is to rotate those lenses so we can change from low power to high power. Down here we have this little piece right here, number 11, which is called the stage clip, and that's going to hold our microscope slide in place. And the stage, this little area right here, number 12, this is actually going to hold or support the slide. So we're going to set the slide on the stage and clip it down with the clips. And then just below our stage is our diaphragm. So this little piece right here is called the diaphragm, and its job is to control the amount of light that passes up through our specimen through the stage and into the lens so that we can see it. So if you're looking in the microscope and it's just really, really bright and it hurts your eyes, you can adjust the diaphragm to turn the setting for the light down just a little bit, and vice versa. And then this piece right here is the light source. That's gonna it's a light bulb, an electrical light bulb that will provide us with light to see our specimen. It's not always a light bulb. Sometimes it's a mirror. The old style microscopes have mirrors, and you would have to reflect the light up through the lenses to see. And then this piece down at the bottom is called the base, and of course the base is going to support the microscope as it sits on the lab table. Now, a couple of things about using a microscope. One is calculating total magnification. So if we wanted to know how much we were magnifying an object, what we would do is take our eyepiece, there's always going to be a number on our eyepiece, and multiply it times the number on our objective lens. So if we were looking in the first example, if our eyepiece were 10 magnification and our low power objective 4, then we would take 10 and multiply it times 4, and that would give us a total magnification of 40. So if we took our same eyepiece of 10 and we had our mid-power objective, which would also be 10, then we would multiply 10 times 10 to get 100. And if we wanted to calculate our high-power magnification, we would take our eyepiece of 10, and our high-power objective will be 40, and so 10 times 40 is 400. Now, when we look at objects under the microscope, what we're going to see is going to be maybe not what we would expect. On low power, if we were to take this little object, this is just a little curly Q that I drew. If we were to magnify that by 40 times, you would probably expect to see something maybe like that. And if we magnify that little curly Q by 100 times, you're probably thinking that you're going to see maybe something a little bigger. Maybe that's not quite big enough. Let's try that again. I'll erase that. You probably are thinking that it's going to be a little bigger than that. Okay, so maybe like that. And then multiply times 400 would be really big, so you would probably thinking that you'll see something kind of like that. However, in reality, our low power objective is probably going to look very similar to what's drawn there. But when we get to our mid power, what we're going to see in reality is something kind of like that. And what's happened here, let me just switch my pen over. What's happened here is that because we're so close to our object, part of it has been cut off because it's no longer in our field of view. So we can't see it because we're so close to it. And then when we go to our high power objective, it's going to look something like that. Again, because we are just so close to our object, a big portion of it has been cut off from our field of view. So we won't completely see the whole object when we get to that high power. So it's really important when you're working with the microscopes to find your object and focus it really good on low power. And you can even use the little pointer. It has a little pointer built into it. I'll just draw it on there kind of like that. You want to make sure that, let me change the color here, that the very tip of the pointer is touching your object so that when you switch through the objective lenses, it will always be visible at some point in your field of view. Okay? Alright, and we will practice using the microscopes, practice making microscope slides, and then we're going to look at some real cells under the microscopes a little bit later in a big lab.